Hey everyone, this is Dr. Hal, host of the GeoTrek podcast. Can you believe that hurricane season 2023 has arrived? It's now upon us. It seems like just yesterday we were documenting Category 4 Hurricane Ian in Southwest Florida, and here we are now in early June, the start of a brand new hurricane season. Well, at this time of the year, we often hear scientists talk about seasonal hurricane forecasting, how many named storms, hurricanes, and major hurricanes we expect to see in the Atlantic Basin. Have you ever wondered what's the science behind seasonal hurricane forecasting? What are scientists looking for? How accurate is it? And what are the other backstories behind this area of science? Well, today we have a very special guest on the podcast, Dr. Phil Klotzbach, research scientist at Colorado State University. He's really one of the most famous people around the world doing seasonal hurricane forecasting. He also focuses a lot on tropical climate variability. He's going to share how he got into this area of science, how the science works, what scientists are looking for, and all kinds of really interesting information, really providing the backstory behind seasonal hurricane forecasting. I think you'll really enjoy this episode of the podcast. If you're new to GeoTrek podcast, the podcast travels the world looking for stories related to extreme weather and natural disasters. We're really looking at the physical processes behind extreme weather and natural disasters. What are their impacts on people? And then what you can do to get out ahead of these extreme weather events to mitigate their losses and make yourself and your community more resilient to anything that Mother Nature can throw at you. So, hey, without any further introduction, let's get into this podcast episode. I think it's going to be a fan favorite with Dr. Phil Klotzbach from Colorado State University. Phil, thank you so much for taking time to come on the GeoTrek podcast.
Thanks so much for having me, Hal. It's good to be here.
Phil, when people think of you, they often think of the seasonal hurricane predictions and forecasting. Could you share a little bit with us about the science behind that? Like, how does that science work?
Yeah, so the science of seasonal hurricane prediction is basically the idea is that, hurricane seasons aren't random. Basically, there are signals in the atmosphere and in the ocean that kind of tip us off to whether the season is going to have above or below normal hurricane activity. And this goes back to the pioneering work of Dr. Bill Gray, who I'm sure we'll talk about quite a bit over the next little bit. Basically, he was teaching tropical meteorology, and I think it was 1982. And he was talking about El Nino, which was coming on that year. And he noted when you had El Nino years, which is warmer than normal water in the eastern and central tropical Pacific Ocean, you tend to get fewer hurricanes in the Atlantic. And this is kind of an interesting statistical relationship, but at that point, no one had really tied El Nino to kind of a lot of the factors that it's been tied to now. And so he did some research, and through research that he did, basically found that when you have El Nino, it tends to increase winds high up in the atmosphere that increase the vertical wind shear, which is a change in wind direction and speed with height in the atmosphere. And when you have El Nino, you tend to get stronger upper level winds, stronger shear, and fewer overall Atlantic hurricanes. Yeah. So that was kind of how it all got started, was with the discovery of this relationship between El Nino, La Nina, and Atlantic hurricanes, and it's grown over the last, this is our 40th year of doing seasonal hurricane prediction at CSU. We use a pile of different predictors, basically wind patterns, ocean patterns, pressure patterns, all spanning the globe, or all various parts of the globe, to try to kind of determine basically how busy the season is likely to be. One other thing that we use now that Bill Gray did not have at his disposal in the early 1980s, because they really weren't around, was climate models. We can look at climate models and look at what they're forecasting for things like El Nino, things like the Atlantic water temperatures, what the shear patterns are looking like. And basically, those models have some skill at being able to predict the shear patterns, the ocean temperature patterns several months in advance. So we can use those forecasts to help with our seasonal predictions as well. So we use a variety of different techniques when we do these forecasts now.
So it sounds like it really started by seeing some of these stronger relationships, and then it's kind of grown through that and improved with modeling over time.
Yeah, that's correct. So, and some of the original predictors that Bill Gray had in his first paper that was published in 1984, we still use today. Some don't work anymore, and that's one of the challenges of seasonal prediction. Is certain things may work well when the climate is behaving one way, and then when the climate's in a different mode, maybe other predictors work better, and certain things that we thought worked well just stop working. And obviously with climate change, that throws another potential challenge into the mix as well. So certainly, we don't, Bill Gray always used to say, you don't just develop a model forecast scheme and just put it on a shelf and never change it. You're always kind of looking at ways to be able to improve these forecasts a bit and keeping up with the climate, which is always changing, whether from natural variability or for human induced causes.
Sure. Phil, I think our listeners would be really interested to hear about your path into this. I know you grew up in Massachusetts, not necessarily a place where people think of like a ton of high-end hurricane impacts. And I know a lot of your studies and work you've done is in Colorado. So I'm kind of curious about your path, maybe from high school through college, grad school. Like, how did you get into this kind of research and work?
Yeah, so I've always been interested in the weather since I was a little kid. I remember like watching that AM weather on PBS back in like those like aviation weather in like the mid to late 1980s, getting up at 5:30 to watch that every morning. So I've always I guess I was kind of born with a defective weather gene, as they say. But growing up in Massachusetts, we don't get a ton of hurricanes, but we did have a couple when I was a kid. We had Gloria in '85, which went into Connecticut, but brought pretty significant impacts. And I'm probably the one that really got me pushed even more towards hurricanes was Hurricane Bob in '91. I mean, landfall in Rhode Island, but brought a pretty large tree down really, really close to our house. And it caused pretty significant impacts where I lived in Plymouth, Massachusetts, and also especially on Cape Cod, a lot of trees down. So that really kind of got me interested in hurricanes. And then, when I went to college in Massachusetts at Bridgewater State, and I was taking a class in climatology, and I was really interested in doing something with hurricanes. And I said, okay, what can I do with hurricanes and climate? And this was kind of before the whole like hurricanes and climate change thing had really come to the forefront. This is in the mid 90s. But the professor at the time said, hey, there's this guy out in Colorado who basically kind of uses climate to forecast hurricanes. And I was like, that guy's nuts. There's no way you can forecast hurricanes on a seasonal time scale. So that was kind of my introduction, was reading through some of his original papers and realizing, hey, this guy's not crazy. He doesn't actually know what the heck he's doing. So that really got me kind of on the seasonal forecasting area. I actually did my undergrad thesis on his research. And then after taking a year off, I spent a year off basically doing GIS and mapping bus routes. And then I decided I really did want to go to grad school. So I applied to a few, but I got a call from Bill Gray offering me a graduate research assistantship at CSU. And between really, really, really wanting to work with Dr. Gray and also absolutely loving being in the mountains, Colorado was a very easy sell. And so I started at CSU in 2000, and I've been at CSU ever since. So they haven't been able to get rid of me yet.
Yeah, that's really interesting. Sometimes I think there are a disproportional number of people in weather and meteorology from the Northeast, right? That I grew up also not that far from the I-95 corridor there in Pennsylvania. Even if it's winter storms, blizzards, whatever, whatever's happening has a high impact, right? I wonder if that draws a lot of us from the Northeast into this field. I was just wondering, because I know you grew up not that far from the I-95 corridor as well.
Oh, yeah. Well, I think New England and the Northeast U.S. has a lot of interesting weather. It's a very active area for weather patterns. You don't get a lot of stagnant, so you get a lot of, like Plymouth, we used to average like 40 inches of rain a year. And it was, there was really no month that it wouldn't necessarily rain. Like you get your winter storms, you get your mid-latitude, you get your thunderstorms in the summer. It's just a pretty active weather region. And it's a lot of fun. I mean, I know like growing up in Plymouth, we were right along the coast. So it was always agonizing trying to determine where exactly those nor'easters were going to track. If they track just to the west of that, the benchmark of 40 north, 70 west, you usually would change to rain because you get more of an easterly wind than a northeast wind. So we changed to rain. So you wake up at like 2:00 in the morning and shovel whatever snow you got before it. Because what happens is you get the warm sector and then it would change to rain. And then you get the cold front coming through in the backside and it would all freeze. So it was always like, basically you wait till it was pretty much done snowing, shovel all the snow before and while it rained, and then of course then you have flash freezing, and then basically your driveway would be a sheet of ice. So I think the Northeast it's a very high. There's a lot of weather going. It's a pretty active weather region, and I think there are a lot of. It is a pretty. I think there are a lot from the Northeast, probably even relative to the population. I know obviously Northeast has a lot of people, but then the other thing I think is interesting too is how many people in the hurricane field got in because of Hurricane Gloria? There's a lot of people from Hurricane Gloria that was.
Well, I'm thinking of Josh Morgerman, right? Josh Morgerman was right there in Long Island. I mean, that for him, I know for me, that was the only day growing up that my school was canceled because of a hurricane. I was in Eastern Pennsylvania. We got 7 inches of rain. It was also Gloria in '85. So for a lot of us in the Northeast corridor, we all remember Hurricane Gloria in '85.
Yeah, exactly. So there's definitely a batch of hurricane people from that storm, and it's interesting because you can see it now, like a lot of the grad students that are coming into the field, it might be like a Katrina or something along those lines. Like there are these big storm events that really will kind of galvanize like the next generation of hurricane researchers. And I mean, it's the same too, like if you ask the meteorologists in the Midwest, usually it was a crazy severe weather outbreak or a blizzard or something. And so it is, I feel like, especially in meteorology in our field, like a lot of people, like if you ask, in some fields, it's like, how did you get into it? It's like, oh, I tried this and it didn't pan out. But meteorology, a lot of them are like, I've been obsessed with the weather since I was, 8, 10, 6, 4, like a lot of it started pretty young.
Yeah, and a lot of times it was a huge high-profile event that triggered it. So, Phil, you were talking about then going from Massachusetts out to Colorado State. You're working with Bill Gray. I think a lot of people are surprised to hear, like, wait, people in Colorado are studying hurricanes, just like a lot of the folks up at University of Wisconsin are doing great work in satellite meteorology, right, for tropical weather. It proves you don't need to live on the saltwater to do amazing hurricane research. I mean, what was that like out there working at CSU, your time working with Bill Gray and your time through grad school and beyond?
Yeah, so just a little bit of background how CSU kind of got into the hurricane business was they CSU decided to start a department in atmospheric science around 1960. And so at the time, the president of the university contacted Herbert Reel, who was kind of one of the really big hurricane researchers at the time. Herbert Reel was at the University of Chicago, which is still nowhere near hurricanes. So he asked Herbert Reel to start the department. And so Herbert came out to CSU to start the department. Bill Gray was actually a PhD student under Herbert Reel. And so so Gray got his degree a couple years after Herbert had left to go to CSU, and then basically Herbert offered him an opportunity to come out to CSU as a faculty member. So he came out in the I think he started officially as a professor, I think in 1967. So the department does a ton of stuff and not just do hurricanes, but we've always had a sizable component of people doing hurricane research and at our university. So there's kind of a nice there's always been a good focus on hurricanes in our group. And I think a lot of it is one of the things that we always Bill Gray used to always say is, one, the storm surge can't get you at 5,000 feet. And he also used to say, you don't have to live on Mars to study Mars. I mean, especially nowadays with the technology that we have, you don't necessarily need to be, right in Hurricane Alley to be able to study, hurricanes. Like you mentioned, University of Chicago, Wisconsin does a ton of work on satellite meteorology in the tropics, and obviously Wisconsin's nowhere near the tropics, but they still can do really good research.
Yeah, for sure. It seems like we do a lot through remote sensing, right, with satellites and these atmospheric teleconnections. It's rare that you're actually like flying into these different long distance areas. A lot of this is sensed remotely, I would imagine.
Yeah, and so Dr. Gray actually earlier on, so he's best known kind of in the general public for his seasonal forecast, but he did a ton of other research, and really kind of his bread and butter was using aircraft reconnaissance data, and a lot of that. So now in the Western North Pacific, we don't fly planes into storms very much. There's a few research missions every now and then, but up until 1987, they flew a ton of recon in the Western North Pacific. And so Dr. Gray had a lot of students from the Air Force who came in and brought a lot of this aircraft reconnaissance data with them. And so he did a ton of work compositing. Basically, a lot of his work was on compositing of hurricane structure. So looking at kind of the internal structure of the hurricane, like, the warm core structure, like exactly like what does a hurricane look like internally? So a lot of that was from this aircraft reconnaissance data he got from the Western North Pacific.
That's interesting. And after the National Tropical Weather Conference in South Padre, you and I were sitting on the bus and we were chatting about that. I think you said that he actually had a whole bunch of research he had done, reconnaissance, that he was planning to do maybe for his research, but there was a mistake or somehow it got thrown out along the way. Could you share that story with us? This is an amazing way that I guess he ended up redirecting into seasonal hurricane forecasting, right?
Yeah. So some of it was in the early 1980s. He had gotten a bunch of new aircraft reconnaissance data. One of his students had left the data, I guess, right next to a trash can. And so a custodian came and threw it all out. And I wasn't here in 1982 or whatever it was, but he went through. I know he had his secretary and all these other students like digging through trash cans trying to find it, and they just couldn't locate it. So at that point, it was like, okay, he kind of had to redirect. And so at the same time, I'm not sure exactly how the timing of all this worked out, but he had a visitor from Australia. His name was Neville Nichols. And Neville was actually doing similar kind of seasonal prediction research for Australia. And so he and Neville chatted for had several days worth of conversations about predictions on seasonal timescales, because Neville noted something similar, that when you had La Nina conditions or you had El Nino, you tend to get fewer cyclones around Australia, which is interesting because basically most of the globe, El Nino actually increases your storm activity. It only decreases it in the Atlantic and near Australia. But the two regions they happen to be working on, they actually had the same sign of
interesting.
Yeah. So he and Neville did a lot of discussion back in the day. And so Australia, I think, was a little more reticent to actually put out these seasonal forecasts operationally because Neville worked at the Bureau of Meteorology, whereas Bill Gray was at a university, and Bill Gray was never one to shy away from putting out something controversial or putting out something, so like, at the time it was kind of a, not scandalous, but it seemed like kind of almost crazy to forecast a hurricane season. But the thing was, at that point, Gray had been in the field for 20 plus years. So he had a lot of kind of street credibility, so to speak. Like, he had done a lot of work. He did a lot of work on Genesis. He had put out, he had put out his various parameters, like why we get storms where we do. He'd done all this compositing work of, why storms form in the Western North Pacific, why they don't form off the coast of Brazil very often, things like that. He did a lot of work on that as well. So he had done a ton. So when he started doing these seasonal forecasts, it wasn't like he was some crazy guy that no one had ever heard of. Like, he had actually done a ton of research at that point already.
Well, it seemed like he was kind of breaking down through the credible science of cyclone genesis, how and where these storms form. So all of that is super valuable for research, even if you're not doing a seasonal forecast, right? So it's just really advancing the science.
Yeah, correct. And so Bill Gray, I'd say, almost everything he did was some sort of like composites, like, okay, we'll take 50 storms and we'll look at this. And then he did it with seasons. Like, okay, let's take the 10 busiest seasons since, say, 1950 and look at the 10 quietest seasons since 1950. Because basically the idea is if you have your 10 busiest seasons since 1950, you differentiate your 10 quietest seasons, and you look at a map of, say, like the wind patterns, if there's basically no signal, if it's a complete white map, like there's no kind of large scale things, and basically it probably has low predictability. Whereas in the case of hurricanes, if you take the 10 busiest seasons since 1950 and difference to 10 quietest, you see a really strong signal for La Nina in the tropical Pacific. You see a strong signal for a warm Atlantic because that provides more fuel for the storm. So there are these kind of precursor signals out there. And so that's kind of how Bill Gray got this whole thing started.
Phil, would it be accurate to say that he was looking at a lot of different data sets, correlating them to see what is happening, and then after that, following up with why it's happening? Would that be accurate?
Yeah. He was definitely an empiricist. So basically, he would find these relationships and then try to understand the physics as to why. And so some of the relationships that he discovered, we don't use anymore. They just don't work for whatever reason. And, he had some physical reasoning, but sometimes I think maybe it was just, a chance correlation. And that's one of the things in the field that you got to be careful with too is, if you're looking at, say, 30 years of data, if you look at enough predictors, you'll probably be able to correlate hurricane activity with, I don't know, pick your favorite sports team's winning percentage or something. Like, if it's a short time period, you're gonna be more likely to find chance correlations. Whereas obviously, if you're looking at, say, 70, 80 years, those chance correlations are going to be a lot less likely to just pop up, just given how many years of data you're looking at.
Right. As the sample size grows, all of a sudden the true correlations stay and the false ones drop out, right?
Correct. Yeah. So one of the things that we're always battling is, the questions that we always have is, do you try to build a seasonal forecast on more years of data where the data is less, basically not as good? So as you go back in time, the hurricane data gets less certain. And also what the atmosphere and ocean were doing. We just have less certainty because we didn't have satellites. We didn't have aircraft. Sure. So the question is, do you build it on more years of less certain data, or do you build it on more recent years where you're more confident in what happened, but you have less data, or the data is not as reliable?
Yeah, I see that in a lot of different studies that look at long-term trends, trying to understand. You're right. Whether it's population studies or diseases, or whether as you go back in time, the data are maybe less quality data, but you're increasing your quantity.
Yeah,
so,
yeah.
I wanted to ask you, how does the seasonal forecasting really differ today versus back in the 80s and 90s?
Yeah, so a lot of it is just access to data. So when Bill Gray started this in the 80s, early 80s, we had computers, but, we didn't obviously have the internet. So a lot of what was done was basically like he would actually call people up and have them send him basically like data from individual weather stations. There's various stations that have been launching weather balloons for decades. So we'd have, get them to send him like paper copies of balloon like data from weather balloons, from surface stations, things along those lines. Whereas now we have all these what are known as reanalysis products. So basically, these are products that are on a global grid. And what you do is you basically take all your observations at any particular time, whether they be from weather stations, from ships, from satellites, and you throw them all into a model. And then the model will basically fill in the gaps where you don't have data. So you basically get globally gridded estimates of what the weather was like at any particular time. And so, the more data you have, the better the observations are, or the better the kind of the reanalysis is. And so, but these reanalysis products are great because then I can just go online, download the data, and plot and make calculations however I want. And those reanalysis products have gotten a lot better even since I started around 2000. Just the models that we're using are just way, way better than they were 20 years ago. So in addition to actually recovering more historical data, we also just have a better ways of kind of like filling in the gaps than we did, say, 20 years ago. And so these reanalysis products, I would say since the late 70s, are quite reliable. As you go back farther, they get less and less reliable. But again, then you kind of weigh in the argument of, do you want to use more data that's less reliable, or do you want to have fewer realizations that are more reliable? And I think both have their benefits and drawbacks to them. So I'd say that's one of the big things that's changed. The other thing, as I mentioned earlier, is just the way that we now use climate models. So climate models in the 80s were just, they were starting to work on them, but we really didn't have much. Whereas now these climate models, and these are climate models for forecasting like a season in advance. We're not talking climate models, say, for climate change prediction 100 years down the road. These are models that are basically say like, okay, what's the weather, what's the climate going to look like for, say, the next 6 months? And, we're not saying, what's the weather going to be like 71 days from now? What I'm looking at is monthly averages. And so these models, sure, basically when you start looking at monthly averages, they do actually show some skill. And the nice thing is these models are also tested on historical data. So we can actually see the historical, basically, obviously, the climate models today say were developed in 2022, but they will test it and say, how well have we had this model in 1986? How well would it have forecast that year? So we can kind of see the track record of the models, which helps us kind of know which ones are quote unquote best and kind of the reliability of those models as well.
Oh, I see. So we can apply some of that newer science and technology to previous seasons and say, how would have this predicted maybe something back in the 80s?
Correct. Yeah. And you can see, because sometimes these climate models struggle with forecasting, say, a certain El Nino event or a La Nina event. For example, the European Center model the last few years has generally been too aggressive at forecasting El Nino. They've been forecasting a warmer tropical Pacific than what's been actually observed.
Yeah, really interesting. Phil, I wanted to ask you a little bit, like, how is accuracy of seasonal forecasting measured? And like in general, how accurate are these longer range predictions?
Yeah, and so, I always say, when they say, like, how good are they? Say, well, that depends on how you keep score. And so, we forecast, say, the number of storms, the number of hurricanes. And so there's a few different ways you can do it. You can just basically look and say, okay, you forecast 8 hurricanes. We had 10 hurricanes. You were off by 2. So on average, the forecast, I'd say, is plus or minus 2 hurricanes is kind of the average uncertainty with the forecasts. We also look at correlation metrics. So how well do your forecasts actually correlate with the observed values? And so when we do that approach, you can basically see the correlations in April are modest, I would say. So we do have a little bit of skill, but it's not great. In June, they improve. And then especially by the time we get to the July and August outlooks, the forecast skill improves quite a bit. And that makes sense since we're closer to the events that we're trying to predict. So a hurricane season officially starts on June the 1st. We really generally don't get much in June and July. The season doesn't really ramp up until August. About 95% of your major hurricane activity occurs after the 1st of August on average. So we do one last forecast in early August, right before the season really ramps up. And, kind of like your day-to-day weather forecast, like the forecast for, when you wake up in the morning, look at the weather forecast for today, in general, it's pretty good. But if you look at the weather forecast on your phone 10 days from now and then verify it, especially in Colorado, there's been times where the 10-day forecast on my phone says it's going to be 75. And, 10 days later when that day actually comes to fruition, it's snowing in 30. So, there's a lot more things that can change the farther out you go. So the April forecast, I'd say, has modest skill, and then the skill improves as we get closer to the peak of the season.
Phil, I'm really glad you shared that statistic about 95% of major hurricanes in the Atlantic Basin happening after August 1st, because a lot of times we get ramped up for June 1st. There's a lot of messaging, a lot of awareness, and then nothing really happens in June and July. People start saying, oh, this looks like a really quiet season, and they might let their guard down. You're saying, hey, hang on a second. Statistically, 95% of these majors are coming after August 1st in the long-term data.
Yeah, and so the season is 6 months long. It goes from June 1st to November 30th. And there's discussion and debate about even moving it back to May 15th because we have had some weak, kind of short-lived storms even in late May. And, there's some physical evidence why I think maybe that's actually not a horrible idea. But the challenge is the season in the Atlantic is extremely peaked. So normally by August 15th, so if we say move the season back to May 15th, you would have had 3 months of the hurricane season. On average, August 15th, you've had one hurricane. So it's a challenge as to exactly how to message the season. Dr. Gray used to actually ring a physical bell every year on August 20th, signaling the beginning of the active part of the season. I think it's like 80% of your storms occur your hurricanes occur between August 20th and October 10th. It's an extremely peak season in the Atlantic, much more peak than, say, the Eastern North Pacific hurricane season, so off the west coast of Mexico, or the Western North Pacific typhoon season. So it's an extremely peak season, which really does make messaging for kind of hurricane preparation somewhat challenging.
And Phil, you said roughly 80% of hurricanes between August 20th and October 10th. That's amazing. That's in about a 50-day period.
Yeah. The season is extremely peaked, especially for the stronger storms. So you can get weak, short-lived, weak storms kind of forming June, July, into November. But to really get like the hurricanes, and especially the majors, it's more and more peaked as you look at stronger intensity storms.
Yeah, Phil, I think that's really valuable messaging, just for for people maybe that may want to let their guard down when we get to early August and nothing's happened. Even look at 1992, right? The A storm, Hurricane Andrew, late August. I mean, so again, people might have said, oh, nothing's going to happen this year. And then all of a sudden we had a Cat 5 in southern Miami.
Yeah, and I can tell you a year like 2004, people said, oh, it's a dud, nothing in June and July. We had nothing in June and July in 2004, and we still ended up with one of the busiest seasons on record by some of these integrated metrics we look at, even with no storms in June and July. So, yeah, the season is very peaked, and you can have screwball years like last year's a great example. We had very little until September. We had no storms in August. And so everyone's like, oh, it's a complete dud. We're getting nothing this year. And we still ended up with 8 hurricanes, even though we had none until September 1st.
Sure. And Cat 4 making landfall in Southwest Florida. So you could have a lot of big impacts when you look at the dollar amount and the fatalities from a season like last year where we did not even have an August hurricane.
Exactly. Yeah. So these seasons kind of have the climatology, or kind of like the way they quote unquote should behave. But then there's a lot of kind of noise around that. Some years you have really busy early seasons, like 2021 was extremely busy through September, and then almost nothing after September. And other years, a year like 2020 was strange because we had a ton of storms through. Through September. We had 23 storms, but only 2 major hurricanes, which is kind of near the average. And then we had 5 major hurricanes in October and November, and previously we only had 2. So these seasons can do really kind of screwy things. Even looking at the overall season is valuable, but then it's interesting to kind of take apart the season and look and see when during the season it was busy or quiet. Yeah,
for sure. No, that makes a lot of sense and very interesting. Phil, what would you say are some of the biggest challenges for seasonal hurricane forecasting?
Yeah, there's a lot of uncertainty. One of the big things is that we don't know exactly what's going to happen with El Nino or La Nina. So, for example, this year, we're thinking, okay, we're probably going to get an El Nino. It's potentially going to be pretty strong, but exactly how strong it gets, we don't really know. Right now, the Atlantic, especially the eastern and central part of the basin, is extremely warm. It's pretty much at record levels for large parts of the basin. So that's, you kind of got these 2 big factors kind of pulling and pushing one way or the other. And so a lot of it is, we don't know exactly how that's all going to play out. And then I think there's uncertainty kind of the forecast of the environmental conditions. And then even with perfect knowledge of the environmental conditions, we've shown that, looking at, say, like, we know exactly what August and September shear was. We know exactly what the water temperatures were like. When you have that perfect knowledge, how well can you forecast a season? And even then, there's still some uncertainty because hurricanes at the end of the day are weather events. And the climate kind of loads the dice to a busy or a quiet season, but there is still noise within that just driven by weather events. So you can have, say an environment where the Atlantic is really harsh, extremely unfavorable for hurricanes, but there's this one little area where it's favorable, and that system happens to find that one little pocket, or vice versa, where things are extremely favorable, but for whatever reason, that storm finds the one pocket that isn't. And so there's just even perfect knowledge of the large scale environment can only give us so much information. So I think, if I had to do this podcast 100 years from now, I'm sure we'll have done a lot with seasonal forecasting, but there's still going to be just inherent uncertainty at being able to predict weather events on climate timescales.
Yeah, that makes sense, Phil. Last year we had 2 tropical disturbances move into coastal Texas, and they just ran out of time and space before becoming named storms. So that could have easily upped our count by 2. So some of these things, it's a fine line when you count numbers, right?
Exactly. Yeah. I mean, and there's cases where, last year we look at, like, in the Western Caribbean, there was a storm that Julia, I believe, that was really, really ramping up and just ran into land. I mean, yeah. You wanted to bet, 12 hours later, had that had 12 more hours of water, that would have been a major hurricane, but it ran into land. And there's other cases where, a storm will come off Africa, and there'll actually be already a big storm in the middle of the Atlantic, and the circulation around that storm, that really strong shear from that circulation will tear apart the storm behind it. And not, obviously, Ian, at the end of the day, obviously blew up and became a Category 4, but Ian was really hampered for several days because Fiona was an enormous storm and had this huge outer circulation associated with it. And the northerly winds at upper levels from Fiona really hampered Ian for several days. And so obviously eventually Ian got going and obviously became a horrible storm. But, had Fiona not been there, Ian would have been, would have probably been a strong storm for a couple more days. So it's these kind of things are stuff you're not going to be able to predict on a seasonal timescale. I mean,
sure.
Good job forecasting it when it's there, and you may know that a few days in advance, but you're not going to know, there's a storm positioned here and there's another storm behind it, how they're going to interact.
Well, and some of those factors are challenging to forecast even for the upcoming 5 to 7 days, let alone at a seasonal scale. So really good point there.
Yeah, exactly. Yeah, I mean, and obviously, like, Genesis prediction is still really challenging. I mean, we're definitely getting better. The Hurricane Center's get the skills improving, but it's still like knowing exactly when a storm's going to form, or there's times where the weather outlook may have a 20-30% chance of Genesis, and then the next day you got a shuffle storm. It's like it's Genesis is a really hard problem, and intensification, while it's gotten a lot better, still can be really challenging predicting exactly if a storm's going to intensify, exactly how much it's going to intensify. And so there's still lots of room for improvement in predictions on day-to-day weather timescales as well as seasonal timescales.
Phil, what are some emerging areas of research in this field, and what improvements do you expect to see, say, in the next decade?
Yeah, so I mean, there's been a ton of work done. So on day-to-day hurricane prediction, I mean, the track forecasts have gotten really good. I mean, there's still uncertainty, but there is definite improvement on that. I think a lot of it is just basically better modeling. We were able to better know. I mean, one of the key things is getting the best idea of what the weather is like now, because when you run a model, and obviously every observation that goes into a model has a little uncertainty associated with it. The temperature thermometer says it's 81 degrees, maybe it's 80.9, 81.1. Like, who cares, right? But those really small errors grow with time, and so basically getting a better and better idea of what weather is like right now is hugely important. And I know in the Hurricane Center, for example, when a storm is approaching land, we have all these satellites that can get us information about the winds around the storm, but launching weather balloons and actually so satellites basically will sense winds and stuff, but it's always in these layers, like maybe 1,000-foot, 2,000-foot layer. Whereas a weather balloon can actually measure the winds, and they can tell you exactly, at 9,237 feet, the winds are this. And that information is really helpful for the models, and that can help improve the forecast tracks. But as these models have gotten better, the last few years, you've actually gotten a lot better at forecasting intensification of storms or weakening of storms. And that's definitely an area I think we're going to continue to see improvement over the next decade. On seasonal timescales, one of the things, it sounds kind of funny, but as all this, we're basically getting a better idea of what hurricane seasons look like in the past. These reanalysis products now are just, they're higher resolution, and they're better able to categorize the uncertainty associated with, a day in 1960 or a day in 1950. So as we get more and more of these historical data products online, more reliable ones, that helps us better calibrate our models, as well as being able to do these kinds of using climate models to forecast the large scale, then using their forecast of the large scale to forecast the season. As those climate models continue to improve, basically just better skill up at, better computers, better initializations, that's going to help our seasonal forecast as well. So I think for me, being able to forecast where the storms are going to track on seasonal timescales, I think I'm not sure ever how much we're going to be able to do there, just because hurricanes are governed by day-to-day weather patterns, exactly how they track, and that doesn't necessarily have much predictability on seasonal timescales. But I think we're going to get better at being able to forecast areas where storms are likely to form, and that makes a big difference. If storms form, say, in the Caribbean, okay, they're going to hit somebody. Like, once it's in the Caribbean, it's going to hit Central America, potentially come up hit the U.S., maybe hit both. Whereas if a storm forms right off of Africa, not to say it can hit something, but those storms are more often the ones that recurve and go out to sea without causing as much in the way of impact. So trying to pinpoint, whether the Eastern Atlantic or the Western Atlantic is more likely to be where the storms form, I think has huge potential as well.
Phil, any last take-home messages or big perspectives you'd want to share with our listeners as we close up here?
Yeah, I mean, I think, the thing is, obviously, seasonal forecasts, I think, have come a long way in the last 40 years. There's a lot of new tools that we're using. And, even since Bill Gray passed away in 2016, I think, hopefully he like what we're doing now and some of the new techniques that we're using. But, I think these forecasts are always evolving. And I think, with time, they will improve. And, say, for example, this year is a strong El Nino and the Atlantic is the warmest on record. We'll know what happens. We'll know. You can model it and say what happens in the model when this occurs, but we could actually maybe even have a realization of that in the real world, which is helpful too. So every year does help us kind of recalibrate our models and help us look at things a little differently. So from that perspective, I think this year is certainly going to be a very interesting one, because even if they say things don't quite pan out the way that we anticipate, maybe we have a strong El Nino and the Atlantic isn't as warm. We'll be looking at like, okay, why was the Atlantic on record warm pace in May and then suddenly not in July, say something like that. So that's the kind of stuff that I think, again, all these seasons are good learning experiences, and will hopefully lead to a continued improvement in skill in the forecast in future years.
It sounds like a very distinctive season with some strong signals, and we'll be learning a lot in the future that we look back at 2023.
Exactly. Yes.
Yeah, Phil, how can people find you if people want to get in touch with you or find you online, hear what messaging you're putting out? How can people find you?
Yeah, so I'm Phil Klotzbach. Best I know, I'm the only one in the world. So if you search Phil Klotzbach, you can find me pretty much wherever. I do a ton of stuff on Twitter. My Twitter handle is @PhilKlotzbach. When I signed up for Twitter, I wasn't really planning on doing much on Twitter, so I did get a really fun, hurricane geeky handle. But if you just search @Phil Klotzbach, I'm there. I don't have the blue check mark anymore. I did for a while, but Elon got rid of that. So no more blue check mark for me, but that's okay. I still think I provide reliable hurricane information even without the blue check mark. And then our website is tropical.colostate.edu. If you just Google CSU seasonal forecast, you can find it there. And then again, if you're interested in seeing what other groups are saying for seasonal predictions as well, seasonalhurricanepredictions.org is the website that has the 28 different groups that are submitting their forecasts. So you can see what the forecasts are, how they're trending with what we actually have observed. And then we usually do a short write-up kind of summarizing what's happened so far and kind of how things are going to potentially trend over the course of the season.
Yeah, Phil, thanks so much for all of that. I'm sure a lot of our listeners are going to want to check in with what you're seeing through this season. And when the Red Sox win the World Series, I do remember you were leaning towards maybe a subpar season, and now they're turning it on. So maybe we'll learn a lot on the baseball side this year too.
Exactly. Yeah, the American League East is quite the division so far, and I think the Red Sox are 4 games above 500 in last place. So it's tough competition, but they're definitely outperforming kind of what I thought they would be doing. So no complaints if they can pull off being a little bit above 500. Because I think when you asked me, I said they were going to win like 70 games. So I'll be very happy if they outperform that forecast. Although I was asked once, I believe it was like 2018, how the CSU football team was going to do. And I said they were going to win 3 games, and I think I got the number dead on. So, you
better be careful. People are going to have you doing long-range sports forecasting too. If you're,
that's the problem is I forecast everything. I'll forecast, but my baseball forecasts have been less than stellar. Don't go with my baseball forecast.
Well, Phil, thanks so much for taking time to come on the podcast. Really excited to keep in touch with you and your research this summer. And I'm sure our listeners are going to love this podcast episode.
All right, sounds good. Thanks so much, Al. Take care.
Yeah, thank you. Phil, thank you so much for sharing your insights. That was a fascinating podcast. I think it'll become a fan favorite because you really explained a lot of this amazing science behind seasonal weather forecasting, as well as the people behind the story. How did seasonal forecasting begin at Colorado State University? And even how did you get involved in this area of science? Really interesting to hear about your personal journey to this area of science. A few take-home messages that I got from this podcast. I thought it was very interesting that you mentioned 95% of major hurricanes happen after August 1st, and 80% of hurricanes in general happen between August 20th and October 10th. You mentioned several times that the hurricane season is extremely peaked. It has this really strong peak really from early August through early October. I think that's really important because every year everyone gets hyped up for the start of hurricane season at June 1st. And a lot of years, nothing really happens in June and July. I think people can let their guard down. What you're saying is when you look at the long-term climatological averages, it's really August, September, and the first half of October that we need to be concerned about. I think that's really important for just giving that awareness statistically and climatologically, that people do not let their guard down. Two other take-home messages I got in this podcast. I thought there were some really interesting life lessons here. The first one, the fact that the janitor threw out the data, I thought that was really interesting. Just the fact that it seemed like Bill Gray and his research group was doing a lot of work with tropical weather reconnaissance data, and the janitor threw out those papers of what they wanted to do, and there they were needing to redirect, and they actually redirected into seasonal hurricane forecasting, which you could argue that's really the most famous contribution of Dr. Gray. I thought that was really interesting because in life, sometimes we hit roadblocks. Sometimes we're going on a path and suddenly the path ends and we have to redirect. And we're really forced with the question, do we give up? Do we have despair? Or do we redirect into something good? In the case of Dr. Gray, what amazes me there, he had done a lot of great research on aircraft reconnaissance data, but then he redirected into seasonal hurricane forecasting. He showed this flexibility and resiliency in his own life to redirect into something that made a incredible contribution to the area of tropical meteorology and climatology. So really cool story there and very inspirational. When we hit these roadblocks in life, don't despair. Sometimes what we redirect into may actually really advance the science and really advance our own careers and help a lot of people out along the way. The second thing I wanted to mention too, I thought it's really interesting that a lot of this research is coming out of Colorado State University. One reason I think that's interesting is that, most people don't think of Colorado as a place where you would study hurricanes. And then Phil, I know you mentioned you yourself grew up in Massachusetts, not a place where we think of a lot of high-end powerful hurricanes. I think this is so important because a lot of young professionals and students listen to this podcast. And when I interact with a lot of them that maybe come from Oregon or Michigan, they might say, how would I get into hurricane research? I'm not from an area that has hurricanes. Phil, you helped remind us on this podcast that you don't need to grow up in Florida, Louisiana, or Texas to make a major contribution to hurricane research. With things really, with the technology today, with satellite data, with high-end computing and analysis, you can really make a contribution to hurricane science no matter where you live. And I think that was a really important take-home message from this podcast today. Again, you don't have to be along the Gulf Coast or the Southeast Atlantic to make a major contribution. You can do that wherever you are. Phil, thank you so much for taking time to come on the podcast. Thank you to our dear listeners that listen every time we produce a podcast. It's great. You can find us on Apple Podcasts and Spotify. And your contribution, your listening and support and sharing this podcast with others has helped us become the #1 podcast in the field of natural disasters. Thank you so much for that support. And thank you again, Phil, for coming on the podcast today. Finally, a special shout out to our marketing team with the GeoTrek project based there in South Alabama, doing an amazing job every week to really edit this podcast, edit the content, and disseminate it, get it out into on the social media and to listeners around the world. Everyone have a great week. Have a safe hurricane season no matter where you are. We'll be back soon with the next episode of the GeoTrek podcast.